Good afternoon. My name is Hunter Carpenter, Senior Director of Public Policy for the Agricultural Retailers Association. Welcome to the first in a series of webinars ARA is hosting in coordination with CPDA, the Council of Producers and Distributors of Agrotechnology. The goal of this webinar series is to develop a uniform industry adjuvant education program for the ag retail industry so we can help our grower customers better understand how the selection and use of proper adjuvants will improve their overall crop protection program. During today's webinar, we will address how to use adjuvants in preventing and resolving pesticide spray mix and compatibility problems. We would also like to take this opportunity to thank Growmark and Precision Laboratories for sponsoring today's webinar. And as we pull up the slides here, we want to also take this opportunity to thank the CPDA advisory working group and acknowledge their contributions in helping plan this series of webinars. So thank you all for your hard work. Today's featured experts are Johnny Roberts and Joe Janowski. Johnny Roberts is Director of Education, Adjuvant Chemistry for CPDA, has 45 years of experience in the development and technical support of pesticide, fertilizer, and adjuvant formulation. 44 of those years were spent with Helena Agri Enterprises, and Johnny is also the co-inventor of 15 U.S. patents related to pesticide, adjuvant, or nutritional formulations. Our other featured expert is Joe Janowski, the Director of Education, Adjuvant Development for CPDA. Joe has over 40 years of experience in the development of adjuvants and spray application technology. 35 of those years were with the legacy Winfield United companies. Joe also holds 41 U.S. and international patents on the composition of new agricultural adjuvants, wind tunnel design, and application technology. He's the author of numerous scientific publications on these topics. So just so everyone knows, certified crop advisors attending today's webinar can earn one CCA program IPM CEU. At the completion of the webinar, a QR code will be displayed for attendees to scan using your mobile device, so stay tuned for that. So I want to remind everyone that Joe and Johnny plan to take questions at the end of their presentation, but you can submit questions at any time using the Q&A function provided by the Zoom webinar application. This webinar is being recorded and will be made available on our website, aradc.org. Webinar recordings and slides are also made available to all ARA members and can be accessed on the member homepage. If you need help logging in, email info@aradc.org. Without further ado, I will turn it over first to Joe Janowski with CPDA for today's presentation. Joe.
Good morning or afternoon, depending on what part of the country you're in. I'm going to kick this off with a little background, some things that both CPDA and the Ag Retailer Association is working on. Endangered Species Act. Most of us don't want to be aware of this, but it is something that does affect our spray applications in the U.S., and it's trying to get worse. The EPA has recently, and they're under, we can't blame the EPA, they're under a lot of pressure from environmental groups, but basically there's a movement to try and expand the use of buffer zones for Endangered Species Act protection. So again, their goal is to reduce pesticide exposure to non-target organisms, including those listed as endangered species. One of the actions that CPDA is doing is to looking at proposing drift reduction adjuvants as a pick list option to help mitigate some of those measures. Next slide, please. So using adjuvants as a mitigation tool for endangered species in lieu of the extension buffer zones is a big win for the industry and grower groups. And the grower groups have been fighting this largely because we know that drift reduction adjuvants can have a significant decrease in off-target movement, and therefore should be utilized to help reduce these endangered species buffer zones. We already have technologies in List and dicamba that are using drift and deposition and volatility components to reduce their buffer zones for those products. And so we're hoping that by moving in the same direction for other products on a voluntary basis, that we may help you reduce having to worry about a 100-foot buffer zone around every field that you're doing. It eliminates a lot of acres in the US, especially smaller fields. It virtually eliminates some herbicide, insecticide, fungicide applications. So next slide, please. So in section 3, the work plan, EPA proposes a menu of mitigation measures that the agency can use across a range of applications and reduce pesticide exposure. This menu interim ecological mitigation includes measures to reduce spray drift, surface water, and pesticide transport. We know how to do this. If we would go back and look at our last webinar last spring on drift and deposition, we've proved very clearly that these things do work. So we know how to reduce off-target movement. I think we just got to more proactively do it, and then hope that we're successful in DC on getting them to believe us on this also. Next slide, please. So before Johnny's going to do the bulk of the presentation, but we do want to talk about adjuvants in general. Back in 1976, how many of you were born by then? Johnny and I are both well out of college, correct? So anyway, only three pesticide labels even recommended a spray adjuvant back then. Wonderful old logos from Atrex and Orthoparaquat. Those are priceless. Don't know who came up with them, but they're very interesting, of those old materials. But they were, along with Roundup, the first to recommend adjuvants. If we look at today, we've got well over 1,000 that recommend adjuvants directly on the spray label, or on the herbicide or pesticide label. So adjuvant use has grown tremendously. It's an important part of successful spray applications. Next slide, please. And there's that number in 23, more than 1,000, and we know it's well over that with all of the private labels and everything. It's probably pushing 2,000 to 3,000 labels say you need to use an adjuvant. So this little bit of a recap before we start the real work. Adjuvants enhance the efficacy or reduce spray application problems. That's really why so many herbicides, insecticides, fungicides recommend them. We have a group of enhancers, and all of these, the non-ionics, the crop oils, methylated seed oils, activators, high-load surfactant oils, those were all covered in last year's webinars. So if you want to go back and refresh yourself on those, please go back to either the ARA or the CPDA websites, and all of those old webinars are up there, along with also the bottom two there, the drift reduction agents and the water conditioners. All of those were covered last year. But today we're going to move to the nasty part of spray applications that nobody wants to hear about. But never a spring went by when Johnny and I didn't get dozens, if not hundreds, of calls on, okay, this is my problem that I've created. What do I do about it? Utilizing compatibility agents and foam control agents are a big, big part of that. Virtually all of you have those in your toolbox. I just think Johnny's going to cover a little better on how we use those more effectively in the rest of the slides. Next slide, please. So here's the agenda. Why are compatibility problems increasing? What types of incompatibilities occur? How to resolve or prevent them? And why should adjuvants be used to help these compatibility problems? So there's the agenda. With that, I will turn it over to Johnny Roberts, who, because he was in the chemistry lab all the time, he took those hundreds or thousands over all the years of calls on these. So with that, I'll turn it over to you, Johnny.
Okay, thank you, Joe. And for some curious reasons, those problems are always on a late Friday afternoon. But give you a little background on the resources I'll be using today. These are two in particular that I'll be leveraging off of. The Purdue Bulletin is an excellent resource. The one, oddly enough, out of Australia from the Grain Research Development is another. But I also want to emphasize that your vendors also are great resources. They can provide technical support. They can also provide bulletins of various types. So there's a lot of good information out there. Just assume that all this information, don't assume all this information is being used by the people that mix the products. Next slide, please. So why are we getting more of these problems? By any measure, they're not decreasing. I can certainly affirm that on my venture into it. There are two things that are driving it. One, the spray application volumes are lower. I mean, and we're to a point we just hope they put water with them. Also, there's joint applications of products being done to reduce fields, trips to the field. Combining pesticide and fertilizer applications, all these things, what they have in common is managing the cost of application, which in many cases is getting higher than the cost of the chemicals. So these things are unstoppable. There'll be more reductions in spray volume. There'll be more combinations of sprays. Hence, the mixing problems are increasing. And at the same time, we've had a shift over to suspension concentrates. And, there's a reason we stopped using and formulating so many of those back in the 70s. And we're back to using them. They solve some problems, but they also add some additional ones, particularly in the area of spray mix compatibility. And the other issue is that by any measure, we're having higher rates of foam. The foaming is increasing. It's not only due to better agitation equipment, but it's also due to the products themselves. Next slide, please. So what are some of the specific incompatibilities that we have to deal with? One, oftentimes we get mixtures that are just too thick to apply or transfer. They separate. We have an old saying in formulations that gravity always wins. And a lot of these mixtures are insoluble and they indeed separate. And there's separation issues that occur both in the tank and then after the fact that we have to deal with. We have inversion issues. Some people refer to this as clabber or mayonnaise. Essentially, it's just a very thick gelatinous mixture that we're not able to easily apply. Foam generation we talked about. We can even have, in some situations, incompatibilities that are due to chemical reactions, and these reactions can degrade the active ingredient. There are antagonisms between some of the spray mix components that keep them performing as we expect them to. Next slide, please. So there are three types of compatibility problems that we deal with. The first one is physical. That is, the mixture is just physically changed in some way. It's too thick, it's too thin, it's separated. It's a physical change that is occurring with the mix. The next one, and arguably the more serious one, is chemical. We are doing something chemically to those components. We are changing their state from one chemical to another. We're changing their ability to be soluble, their ability to even be absorbed. So that is probably the most serious of the three that we'll be dealing with. The third one is what we call antagonism. And what they're referring to is that there's one or more components where the mode of action is counteracting the other or just doesn't get along. And unlike physical and chemical incompatibilities, antagonisms often give no indication that there's a problem physically. They mix, they spread out readily, but then you wind up with reduced weed control or some other kind of detrimental fact that was not what you expected. Next slide, please. So what are the general guidelines? We've talked about correction as the title of this presentation, but in reality, prevention is the preferred way to ensure spray mix compatibility. And oftentimes we have a saying how dilution is often the solution. That's easy for us to say in the lab. We know that we're dealing with the logistics of having to use large volumes of water, but oftentimes dilution is the solution. The other problem, and we used to stress this so much where people don't step on Superman's cape, don't spit in the wind, and never mix pure undiluted chemicals with one another. They should be discouraged. A lot of these problems are due to pre-mixing of undiluted chemicals. In most situations, they are formulated, they're designed with the expectation that they're going to be mixed with water. And when you start mixing them directly, you can get all kinds of things. And it should be common sense. But at the same time, I know that we're in the real world of weather and equipment breakdown that can delay when we do apply these spray mixes, but applying them as soon as possible is always the best course. And then to conduct jar tests, when you don't have any experience on a particular mix and you have no label or manufacturing guidance on that mix, it's always wise to conduct what we call a jar test, which is essentially testing bid mason jars or 5-gallon buckets, the mixture that you're attempting to do before you mix it. There's an old African proverb that only a fool tests the depth of the river with both feet. This is using 1 foot in a small, controlled manner. While they can head off a lot of problems, both mine and Joe's experience with jar tests has been that farmers don't conduct them. Their expectation is that the vendor supplying the chemicals, the salesperson, the applicator themselves, they are the ones that will be conducting these jar tests. And then the other important thing is to recognize that addition order matters. Next slide, please. Real world pictures of spray mix compatibility problems. These are all physical incompatibilities. And the big thing to keep in mind about physical incompatibilities, they're usually reversible. We can fix these things. We'd rather prevent them, as I stressed up front, but we can fix them most of the time. Chemical incompatibilities is a whole different issue, and they may not be reversible. So we'll be talking about both types. Next slide, please. So I stressed how addition order matters. And this is one of the key issues of preventing these problems. And really the basic goal in addition order is to give each component individually the chance to disperse and or dissolve in water before adding the next one. Here again is my bullet about never allowing undiluted components to come in contact with one another. But in many ways, the addition order is driven by the type of formulation. Next slide, please. So, the most time-consuming part of preparing this particular presentation was really getting into what I would call a agreed-upon addition order is. And what I have here is a hybrid of all the various recommendations that I could find. But we feel that this is closest to being a good general recommendation on mixing order. The first thing we do is we start with half the amount of water or fertilizer that we anticipate using. And here's a key function. When we get to the adjuvants, we're going to talk more about detail on spray mix compatibility and foam control agents. They go in first. They work better as preventatives than curatives. And the next step is getting the things that don't dissolve in water, the formulations that require suspension in water. And these are typically suspension concentrates, water dispersible granules, wettable powders, microencapsulates. These things need to be pre-slurried before other components are added. There are creative ways out there on how people do that. A lot of mixers will pre-slurry these materials in buckets where they transform over to the bigger tanks. That's fine. Just always remember, don't do that with one chemical on top of another. Then we'll add the rest of the fertilizer, and that followed by the things that are water soluble. There are both water-soluble powders and liquids. They are most times designated as such on the labels. And then the very last component we add tend to be the oil-based adjuvants and emulsifiable concentrates. These are materials that go in last. Now, I've added some caveats. You will note out in the real world that there are drift reduction agents. A lot of them have their own specific mixing order. Of course, with those situations, we always defer to the product label. And then we also have some pesticides now that have specific mix order instructions. Again, we defer to those product labels when that occurs, and they're there for a reason. Someone had a reason to recommend it that particular way, so we'll certainly defer to them. Next slide, please. So getting into the adjuvant specifically, and we have this very useful tool out in the marketplace. Very few retail locations do not have access to them, and they are called compatibility adjuvants. They're usually mixed blends of anionic and non-ionic surfactants. Their mode of action is based on dispersion, their ability to disperse and thin these thick and collaborative solutions. And then as a result of using them, you wind up with something that's thinner and more uniform and easier to apply. Many of them also have a wetting action that is very useful in getting some of these dry and hard to disperse suspension concentrates dispersed. And the thing to keep in mind about them, they function both as preventatives and curatives. But as we get into specifics here, next slide, please. They work better as a preventative. And what we have here is a picture, and this is a classical fallout of a suspension. I'm not sure which one it is. It's probably atrazine, if I had to guess. And worst case scenario, it's settled out. It's been allowed to stand overnight. And now we have this thick, undispersed material in the bottom of the container. And when we add the compatibility agent, either before or after, in this case, it becomes loose. Now this is something we were able to re-agitate, get resuspended. And I use this point to stress how these are not miracle materials. Things that are not suspended are not magically going to be so. You still have to apply agitation to these materials with or without the compatibility agent. They won't magically resuspend on their own just because you've added this compatibility agent. Next slide, please. So how do we use them? And what you'll find, the majority of these materials, these adjuvants, have a 1 to 4 pint per 100 gallon use rate. You might ask why such a range. The rule here is that if you tend to use them proactively, if you use them as a preventative, you can make that lower rate work. The higher rates of these materials tend to be incurred when you use them after the fact. If the spray mix has a fertilizer in it, always add it to the fertilizer first as a general rule before adding any pesticides. If we get into a situation where the monster is already there and we have to use it later, it may most likely take a higher rate, up to 4 pints per 100, with agitation as you're applying it. Another thing to mention on this deal of using them, some of these mixed incompatibilities can be so severe, you literally have to treat them and allow them to stand for 24, 48 hours before they're loose enough to apply. Obviously, nobody wants to do that. But again, another good reason of why you should be using them proactively. Another issue that we want to stress, a majority of these compatibility agents tend to lower spray mix pH. It's in the sort of the basics of the chemistry of it. That is okay for most of the applications, but in others it could be a problem. So if you have a spray mix like a fixed copper fungicide that does not need to have its pH lowered, be aware of how most of these compatibility agents do lower pH. And again, not a miracle maker, though I have to admit they have bailed me out so many times. I consider them that way, but they may not necessarily correct chemical incompatibilities, which we'll be talking about next. Next slide, please. Okay, here's where we're getting into the serious stuff. More than a physical problem of being too thick or too thin, we are actually breaking down active ingredient. We are preventing active ingredients from being absorbed. We're preventing active ingredients from dissolving in water as they were intended. We are impacting their ability to form or be absorbed, and probably the scariest scenario, we're increasing their crop injury potential. Next slide, please. Some specific examples of that. Probably the one that is most understood and is we're aware of is hydrolysis. And this is where the active ingredient actually decomposes. These are problems that typically happen at pHs greater than 8. Some examples, things like Captan, Carbaryl, a lot of some of your, almost all of your organophosphate carbamate insecticides, or at least the ones that are left on the market, they have a real issue if the pH gets too much above 8, and they can actually hydrolyze. And the problem with this is you don't see it. I mean, it happens. It's very sprayable. It's unclabbered, but it's a serious problem. Another issue that does make its appearance, makes its effect known, is when you convert a water-soluble pesticide into an insoluble one. The classical one is 2,4-diamine. You get the pH too low, it will salt out of solution. Fertilizer can also make it salt out of solution due to some chemical reactions. Another one is deactivation of ionically charged active ingredients. The classic example here is paraquat. Mixing suspension or clay-based fertilizers with it, deactivating the cation itself. Glyphosate also has a deactivation potential with certain nutritionals and things that you add to it. And then conversion of the active ingredient into non-active plant toxic forms. Next slide, please. This is a classic problem, and unfortunately it's one that we deal with every season. And we have a large use application of what we call fixed copper fungicides. They're under a lot of different brands, typically based on cupric hydroxide, cupric sulfate, things of that nature. And what they all have in common is that they're insoluble in water. And this insolubility is when it's at an alkaline pH, typically above 8 or 9. Some of them are formulated even higher. That is in that form, the active ingredient is safe at the rate that it's intended. If you drop the pH of a spray mix that contains these copper fungicides and you get below 5 in particular, it magically becomes clear. It's a great science fair project. You go from an insoluble state to a soluble one. So it's going to spray out readily. In fact, it may even spray out better, but unfortunately, your potential for crop injury goes up dramatically. So this is something that you manage, or you have to manage and be aware of. It's still a problem, an issue that occurs. Where it most often occurs is when you add acidic fertilizer products to it, and you drop the pH, everything mixes fine, but then you get into this potential for crop injury. A lot of the labels warn about this, but some of them more better than others, but certainly be aware of it. Next slide, please. So how do you prevent and resolve chemical incompatibilities? Well, again, I'll stress it again the third time, we avoid premixes of undiluted products, and talk a little bit about that from the standpoint, not all these premixes occur from just mixing them one-on-one in a bucket somewhere. In some of your induction systems, they instruct you to flush water between each chemical you induct. Oftentimes that water step is left out or shorted in some way. That's where you get into this direct contact problem. And the result is one of these chemical, or could be one of these chemical incompatibilities. We always stress when we know this is an issue, always check your final spray mix pH. At one time, we were forced to use cumbersome litmus paper and things of that nature. Now we have access to very inexpensive portable pH meters that allow us to do that. If you have
and Johnny, those are extremely cheap too. I mean, they're cheap.
Yeah, they're so cheap.
Yeah, they're not hard. You can use it for a month and throw it away and buy a new one for $18. So
yes, Amazon has made it a very affordable solution.
Yeah. And I think the other thing is, have an idea what your starting water pH is. It's very simple. You should know your hardness and all that, but a lot of your spray waters, if you're setting in between 6 and 8, you're going to be fine. but you need to know if you got your normal spray water is above or below that. And that's fairly easy to find out, and you can eliminate some issues by knowing where you're starting with the starting pH of your water.
Yes, to measure is to know. And one of the things that that we have trained applicators on is this fact that the really acidic and alkaline materials that are out there, they're the source of a lot of these problems. And now, thanks to the GHS requirements on labeling, you have a good indicator when you have a very acidic or highly alkaline product. They will be labeled with the infamous corrosion sticker. Hard to miss the picture of a burning hand. That is an indicator that it is very acidic, very alkaline, one of the two, and it is always wise to dilute those materials in as much water as possible before you add other components. And again, back to dilution being the solution, you can really tone that aggressive pH situation down if you pre-dilute it. And you have another option here, and I mentioned how oftentimes these chemical incompatibilities are not recoverable. That may not always be true. There are ways to adjust spray tank pH. Again, using your inexpensive and widely available pH meters, of course. There are ways to adjust the pH up or down with various products that you'll have access to in the marketplace. Next slide, please. So moving on to foam, and Joe and I had a real good discussion on this one, and the big thing to realize here that this is a lot more than a nuisance. You know, we're dealing with a problem that impacts your spray calibration. There's exposure issues. You know, we don't want toxicants in a foam that is easily blown to the next site or a worker comes in contact with. There's a link between excessive foam and increasing drift, and boy, the problems with it appear to be increasing. I know from my experience in tech support, foaming typically is our #1 application complaint. Next slide, please. So why are they getting worse? And here again, our lower spray application volumes and higher agitation speeds are certainly making it worse. And then the more components we add, the more foaming we tend to get, because a lot of these materials are formulated with surfactants. We have the adjuvants components oftentimes. There is a greater use of suspension concentrates, and those things in themselves have a lot of foamy surfactants that tend to add to the issue. And another thing that people don't realize is that as we use less emulsifiable concentrates, ECs, you know, a lot of these ECs had the tendency to cut the formation of this foam. It tends to be the nature of some of the solvents and the oil-based materials. They tend to foam less. Well, we're replacing them with suspension concentrates that foam more excuse me, foam more. And of course, the foamiest by far of what we have to deal with, glyphosate and glufosinate materials. Those materials themselves in a low volume, high agitation system are basically foam generators. Next slide, please. So how do we manage it? Fortunately, we have some great tools on managing and basically preventing it. If you have a choice, you know, if you're having some foaming issues and you have a choice between an oil-based adjuvant and one that is not based on oil, the oil-based adjuvant will tend to foam less. And a lot of materials, and you'll see this in the marketplace, are being formulated with foam control agents in them. So you may have a chance to try or use one of them, but there is help on that side of it. Foam management itself, we have access to materials that both prevent and reduce it. The thing to stress here, these materials work best when added first. Notice the use rate range. I have as low as a 1/2 to 4 ounce per 100 gallons as the use rate range. And that is because the tendency of people to use them after the foam is formed. I don't know, it's something in the human condition. It's like popping bubble wrap. We want to spray that foam down after it's formed and see the see it go down. The reality is they work much better used preventatively. And you can make a good argument that every application, the minute it hits water, has the potential to foam. So a low rate of a foam prevention agent will head off the formation of the problem to begin with. Be aware that some adjuvants and some actual pesticides have surfactants that produce foam that may require specialized foam control agents. The best example of that, there may be others that I know of, are organosilicones. These materials may require specifically designed foam reduction agents, so be aware of those. If you get a foam that is just not responding, it may be due to one of these situations where you need a more specialized defoamer. Next slide, please.
And I'd add to that, Johnny, adding them first. We're hesitant to do it because of the cost factor, but especially if you know you've had a history of foam, just put it in ahead of time, and you're going to put a lot less in. It's going to be a lot more cost effective. I had a conversation with a company that sells drones, and they try and fill those tanks in a matter of a minute, and they always have foaming problems. In my recommendation, I'd just treat all your water you're ever going to use and just have your anti-foam in there ahead of time. And,
yeah, my experience is it's just more fun to add them last, right? You
well,
just
it
love
is,
to
yeah.
see
I mean,
that
especially
foam go down.
those
But
dry sprinkle-on ones. Oh God,
yeah,
they were so cool. They knocked it
yeah,
down. But
oh yeah,
you know what? If you want to save time and money, put them in first. So.
absolutely. They work so much better. So this last one, and the one that we'll be able to go through pretty quickly, because preventing antagonisms is strictly one of knowledge. And antagonisms occur when, and particularly with herbicides. I'm not aware of ones with insecticides. Well, I am aware of some with fungicides, and mostly herbicides. And they occur when a tank mix of multiple herbicides results in weaker weed control than when the herbicides were applied alone. And we also have the situation where some active ingredients are antagonized by spray water quality. We had a great discussion on that in the case of glyphosate and glufosinate in a previous seminar. So those are classic antagonisms. But the big thing here is that usually there's no physical indication that there's any problem going on. It mixes well. It's fine. There's no clabber. In many cases, they're fully water soluble. Clethodim will mix with dicamba and 2,4-D all day long, but there's no question that one antagonizes the other, particularly the 2,4-D antagonizing the grass control. Next slide, please. So how do we resolve or prevent them? Really, prevention is the only option we have here. We can't go back and kill weeds that we've missed unless we respray. So oftentimes it is rate and timing dependent. So you're really at the mercy of that manufacturer to supply you information of where there's antagonisms. The University Extension Service is doing a good job of putting information out there about them. I'm citing the NDSU's weed control guide in particular. That is by far the best discussion on how to manage herbicide antagonisms that I have seen, outside of what manufacturer may tell you. And oftentimes you can prevent them just by changing the rate. So it's one of those things just to be aware of. And when we get to the water quality issues, in particular, the big ones are glyphosate and glufosinate. We can address those with AMS and water conditioner type spray adjuvants. So again, it's just one thing to be aware of. The big thing is just be aware that they oftentimes do not present themselves in any kind of a physical way. They just unfortunately present themselves as reduced weed control. Next slide, please. So, we've added, you've got one more layer of complexity to manage in your pesticide applications. It seems like they're getting more complex. And I've always stressed with tech support people and agronomists and sales representatives, hey, the more complex this gets, the more you're needed. Complexity is job security. So what should be in your toolbox? a cheap, inexpensive pH meter. You can get those off of Amazon. They almost give them away. Have access to compatibility agents. Jar tests, always do those when you're in the unknown. You have no guidance, you have no experience. Be aware that the grower expects you to conduct them, and the grower most likely won't. Rely on the resources that are out there. There's some great information on the internet. I supply 2 of them, but your vendor can also supply good training and background on how to use them. Foam control agents, and I've got little Bo Peat ammonia listed here. One of the things you may get in situations where you don't have access to adjuvants that raise pH. There's not a lot of them, but there are some on the marketplace. You are seeing more of them. But in that event, little Bo Peat ammonia is a great go-to if you've got to go up in your pH. And another thing I'd like to stress is that, boy, document these problems and solutions. Take pictures, record them in whatever way you record information. It's very frustrating from a tech support role that I had, how we just kept seeing the same problems repeated over and over and over. And you find that oftentimes it's because the information on how to prevent or solve them just wasn't shared. So never assume that that information is out there. Next slide, please.
Yeah, I'd say document them and then communicate them within your group.
Yeah.
I mean, if you're at a retailer that you got 10 different applicator units out there and you run into a problem, make sure you, in today's world, it's a lot easier than when Johnny and I started. You could text out to the rest of your team, hey, I had this herbicide and this, and I thought that this is what I ran into. And you can save the company a lot of problems by communicating. And then you also got all the information to try and get the fix in. So.
Yes, I had a coworker had come up with a good term for it, and she referred to it as tribal knowledge. There's a lot of tribal knowledge out there that is not down on paper, and by all means share that. And when you get to this, here's another, from a grower's perspective, they view this, here's another cost, here's another input I have to add. You run into objections. So we always do an exercise, or is what are the grower objections to using adjuvants to overcome compatibility issues? And the one that you always hear, if they were really needed, the manufacturer would build them in. And yes, in many occasions you can, and some manufacturers do, but the dilemma, the problem they have is that one size doesn't fit all. There are too many variables in spray volume. There are too many variables in fertilizer. There are too many variables in equipment. So it seems like we fall back to these spray tank adjuvants to fix these problems. Another comment you hear, well, I've never had mixing issues. It's always mixed fine. So I'm assuming that's the way it's going to be in the next season as well. Realize that pesticide and fertilizer formulations change. Fertilizer formulations can vary just from the different, go down the road, and the 34 or the 28 is made a different way. Never assume that just because you had no problem in the past, you won't in the future. Another pushback you might get is, well, I don't know when to use them. I'm just sort of, I've had problems with foam. I've had problems with this mayonnaise, but I never know when I would need them. And you can make a good case that problems like foaming and getting pesticides to mix with liquid fertilizer, they're such a common and almost guaranteed problem. Use these materials up front to prevent them. It is much easier to prevent than it is to cure. And at the end of the day, the biggest benefit that we can provide our growers is saving time. And that's what really, at the end of the day, what a lot of this is about. And then, of course, they just cost too much. And the issue there, what is time worth? It has a price too. It has a value. And we're really should be in the mindset of preventing these problems, not trying to fix them, but prevent them. Next slide.
So Johnny, I'll add a little story to this when you go back to that. I've never had this issue before, and this is a true story. It's not made up. And a long time ago, but four applicators at a retail outlet. They were all spraying exactly the same thing with the same equipment. 2 of the 4 had no problems. And the other 2, every tank mix, they had compatibility issues. And so being asked to decipher that, the bottom line was the 2 that were not having problems smoked. So they were taking more time to have the cigarette break while they were mixing, and they had no problem. So to trying to do it fast, it did not work as well. And this is an honest to God true story. That was the only difference between having a problem and not, taking longer to mix the things together, not slamming them all in there. So and that is true. That's not that was not made up. It's on. It was probably 20 years ago, but I never forgot that. To say, guys, take your time when you're putting this together. And I'm sure the other 2 were slamming them in the inductor system, and because they're trying to do it quicker.
So their cigarette habit was giving these materials the opportunity to disperse like they should be.
Correct. That was the bottom line. Yeah.
So what does all this mean? What's the bottom line on all this? And that's what we want to wrap up with here, is that always defer. You're getting better directions on these labels. They are warning you more about incompatibility potential. You'll find references to using compatibility agents, particularly when fertilizer is involved. Meet this minimum spray volume. Those minimum spray volumes are on there for a reason. Oftentimes they're there for efficacy, but they're also there to ensure compatibility. When they have pH guidelines, follow them. And they're putting a burden on you as an applicator or mixer to really know the pH of your spray mix. So follow those guidelines. The other guideline, again, don't step on Superman's cape and do not mix undiluted chemicals. Add your oil and solvent materials last. One of the worst things you can do is add an oil or solvent-based material directly to a dry WDG type material. Pre-dispersing or slurring SCs and WDG products is a great tip. A lot of people have ways to manage and do that, and that tends to mitigate the problems. And then always include, and I would say without exception, a foam control adjuvant in with your spray mixes. Yes, it sells more chemical. There's a motive there, but at the end of the day, we're trying to prevent these problems. We have a motive and an incentive for that grower to get these materials on target and off of the workers that are dealing with them. So foam control agents should be added first and to every application. So next slide, please. That wraps it up for the presentation itself. It can be a complex target, but as I mentioned, that complexity is the reason we need tech support people, and tech support people also include the agronomist and the sales reps. So here's the details on getting your continuing education credits. So you can follow up and get those.
Thanks so much to Johnny and Joe for today's presentation. That was fantastic. Do have a couple of questions in the chat. Not sure I understand the first one. Is this Wales/Dales? Not sure what that one is. We do have one that says, does hot loading change anything that you have recommended today? Should the hot load be used up after so much time after being mixed?
Boy, I'm not quite. Joe, do you know what a hot load means?
Well, I think what they're saying there is they're sending their water out with several items already in it. Like I know retailers that they're putting in at the plant, they're sending out their water with their adjuvant systems already in it. And so again, I think it goes back to, if that's the case, what you're asking about is they're probably already mixed well. So that's the key, is it's already in water. Certainly your water conditioning agents it could be done that way. And then the last part of it is, should hot loads be used up after so much time of being mixed? What you'll see in the hot loads, if you tend to let them set out and they get hot, you have two things that could happen. You could get bugs start to grow in them. And if there's ammonium sulfate, you get ammonium odor coming off of that. So it's best to keep them, to use up those hot loads fairly quickly if you can. Because if you get, if they set out, 250 or a 500-gallon load and they're sitting there for 3 days, you got a chance for bugs growing in them. So yes, I'd use them up quick.
The next question, I'm gonna have to go back a couple slides. Let's see. It said next last slide. What is the second use of adjuvant in the third column?
I'm sorry, the second use?
Yeah. Just reading through the question, I'm not sure exactly what they mean. If you want to reword that. Second point in the third column.
Add compatibility agents with pesticides and fertilizers or with thick clabbered mixtures.
Just means put them in right away. Yeah.
Yeah, that's
looking for more info.
Yeah, this is where I would you already have the problem. It's clabbered, it's mayonnaised. Those where you can add the compatibility agent directly to that clabbered mixture. You've already got the monster. You didn't prevent it. They can be used to thin that mixture out. But at the same time, you're going to thin it up. I mean, that's what they do. They get thinner. And so the agitation has to be maintained when we do add them last after this, as after the fact, so to speak.
Okay, a couple more questions. Do you have a preferred foam kill or anti-foam product? And what tank mix compatibility agent do you recommend?
There's some great ones, in the marketplace there. You're not going to have trouble finding good quality foam prevention or compatibility agents in the marketplace. There's some good ones there. There's questions you can ask when you're looking for them. Does this foam control product, is it a preventative and a curative? Does it do both? Does this compatibility agent, how do you recommend I use it? Do I add it first? Do I add it last? Can I do it both? You'll find that there's a great commonality between the compatibility agents functionally. But there are variations. It's like buying cars. Some of them have defoamers. Some of them have water wetting agents added. That's the nice thing about having such a competitive marketplace. You have products with a lot of options.
Next question.
Johnny and I did talk about the compatibility agents. I think that's with the newfound problems that we're having, I think there is some space there for chemists to try and look at. I mean, over the last several years that I was still at an organization, every time an alert supplier come into it, hey, you got anything new in compatibility agents? Because we're getting more and more compatibility problems. And I think that's a space that some good chemists could tackle with some of these new issues, is can we make a more robust compatibility agent than what we have today.
Yeah, I will second that, because really the technology we're using has been around since the late 60s or early 70s. It's had some refinements. We've had some people, some of the early ones were flammable. They're not anymore. But it is a space that as we get more and more problems in this area, that we'd love to see some innovation. There's some, but there could be a lot more.
Next question, can we expect fixed wing or drone applications potentially to have more compatibility issues than ground rigs?
Yes, because of the lower spray volumes. It is inherent that you're going to run into more problems. And both of those also, they're trying to fill their tank so rapidly that they almost always need to have their water already have an anti-foam in it, because they're trying to fill a small tank very rapidly, and you're going to have foaming issues for sure. But because of the lower spray volumes, I think that's a given. A good friend of mine just retired recently, and one of his things that he always said: anytime you have more products than gallons per acre, you're gonna have a problem.
Next question, can mineral oils create compatibility issues? And if so, when?
Yes, if they are not properly emulsified, they can, and the technical term is invert emulsions. They will thicken rather than emulsify in the way that we need them to be. So yes, minerals can cause compatibility issues if they're not properly emulsified.
Next question, compatibility agents generally use anionic surfactant basis. Many biologicals may be killed when tank mixed with anionics. Any recommendations?
That's very true. And typically compatibility agents work by dispersing, and that dispersion comes from a heavy anionic charge. And I could see where something like that would be more detrimental to a biological.
Yeah. I think, Johnny, again, it gives an opportunity as to develop some new technologies that could be used more successfully with the biologicals.
Yeah, that's an opportunity waiting. And if you're in a situation where you're having some compatibility issues, and what's out there now is not is detrimental. And it's not a Hail Mary. It's something that you can try. Sometimes we have used it to get out of trouble. Is go to a non-ionic surfactant. They may, and I use that, underline that, they may correct the problem. They're not as effective as the anionics, but being non-ionic, they tend to be a little bit more biologically neutral. And I would try that until we develop or see something on the market that is more specifically designed for biologicals.
And our final question, do these products have to be on an EPA approved materials list?
Yes, they do. All adjuvant components, if they're going to go out in a spray mix that in turn is going to go over a food crop, we are limited to the things that are on we call it the inert list. Now, if we're not going over a food crop, they don't have to be. But if it's over a food crop, yes, it has to be on that approved list.
All right. Well, thank you again for attending today's webinar. We want to thank again our webinar sponsors, Growmark and Precision Laboratories, for their cooperation and their support here. We also want to thank Johnny Roberts and Joe Janowski with CPDA for all their hard work putting this presentation together. There will be more presentations in this webinar series. Those will also have CEU credits available for those presentations. Our next one is adjuvant application with pre-emergent herbicides, scheduled for December 7th at 1 p.m. Eastern. So please tune in for that one. That webinar will be sponsored by OroRZ and Helena Agri Enterprises. So thank you to those webinar sponsors as well. And if you have any questions in the meantime, you can contact me directly, hunter@aradc.org. For how you can access webinar recordings, past recordings, or any questions you want me to push along to our friendly folks at CPDA, I'd be happy to do so. So Johnny, Joe, and Terry, thank you to everyone at CPDA for this great presentation. Have a great day.
Thank you much. Appreciate it. Have a wonderful day, guys. Thanks.
Thanks.